So this is a limit definition of the derivative problem. Our function is f of x equals x squared minus 3. And the limit we're trying to find is limit as h tends to 0. Sorry, that's an arrow, supposedly. Tends to 0 of, I'll just put this in brackets, f of h plus 3 minus f of 3, all divided by h. Let me just check to make sure that's correct. It is correct. Okay, so the first thing we're going to do is just take our function and substitute in the h plus 3 and the 3 values. So I won't write limit as h tends to 0 here, it's just sort of implied. This will come up more in the last step. But first thing we do is we plug in for h plus 3. So we get h plus 3 squared minus 3. And then subtract off the f of 3, which is just 3 squared minus 3. These are both brackets. And this is all being divided by h. So all we have to do is just distribute this out. H plus 3 squared, I'll just kind of do this over here. H plus 3 squared means h plus 3 times h plus 3. We distribute by foiling, so h times h, which is h squared, h times 3, which is plus 3h, 3 times h, which is plus 3h, and then 3 times 3, which is plus 9. So this all simplifies out to h squared plus 6h plus 9. We can rewrite this as just h squared plus 6h plus 9 minus 3. And then over here, 3 squared is 9, minus 3 is 6. So this just becomes minus 6. This is all still being divided by h. Now all we have to do is simplify. So 9 minus 3 is 6, minus another 6 is 0. These things just cancel right out. And all we're left with is just h squared plus 6h divided by h. And this is what we're taking the limit of. So in other words, the limit as h goes to 0 of h squared plus 6h divided by h. This is where it gets a little bit tricky, because if you immediately try to plug in 0 into all the h's, we'd get 0 divided by 0, which is an indeterminate form. So we want to simplify this a little bit. We divide an h out of everything. So this is equivalent to the limit as h goes to 0 of h divides from the bottom and both pieces in the top. So we get h plus 6. And now as h tends to 0, this whole thing just simplifies down to 6. You can effectively just substitute 0 into everywhere we've seen h. We want to think of it as h is going to 0, so it's getting closer and closer to 0, but never quite reaching it, because that's what this definition is of the derivative. But basically, we can just plug in 0 in effect and get that this is just equal to 6. So this whole thing simplifies down all the way to just 6 by just plugging in some values. I'm assuming you're in the beginning of a calculus course, so you'll see later on that there are certain rules we can apply here to just skip ahead, skip all this work, and just find the value of 6. But effectively what we found is that at the value of x equals 3, our derivative is 6. So the slope of this function, this parabola, is 6 at that point. Thank you for watching. If you need help, please go to my profile. I'm offering help in math at all levels, pretty much whenever you need it. So take care, and thanks again.